We're Sentia Health. We're in the business of streamlining and automating processes and have even automated the production of new software. Today we are going to talk generally about the state of health insurance in the US and medical software in particular. Today we are going to discuss what the Epics, Cerners, and Athenas of the world are doing right and wrong, and what could probably be done better. Epic Systems electronic health record is used in about 40% of hospitals and has a chart for over 54% of the patients in the United States. While this seems impressive, Epic uses an ancient 1960s programming language called MUMPS that has an integrated key-value style database. MUMPS is only used for medical records and therefore is not well maintained nor kept up to date with current philosophy in programming. This makes it extremely difficult and expensive to find new programmers. The key-value pair is wholly unstructured and makes remembering what key the data is stored in a challenge. The designers of MUMPS will tell you that the key-value pair makes data access fast, but the reality is that a more traditional, though newer, relational database management system, or DB engine, is far faster with batch write caching, indexing, table statistics, and other magic to help make reading and writing data far faster. Further, the DB engine maintains a transaction log that in the event of a crash can be played forward against a backup and replay all the database changes since that backup. Cerner is written in everything but MUMPS. Oracle bought Cerner in 2022 and is slowly rewriting it a piece at a time. This is probably because it is written in hundreds of disparate programming languages and consequently is utterly unmaintainable. This is a trap that most software falls into. We as a population can't afford to make those same mistakes that Cerner did with patient care. The U.S. Department of Veterans Affairs, VA, spent $16 billion on an Oracle Cerner deployment and stated, Oracle had inherited that deal as part of its Cerner acquisition, and with it the news that between the Cerner go live in October 2020 through June 2021 alone, it had failed to deliver more than 11,000 orders for requested clinical services owing to alleged system design errors. U.S. Department of Veterans Affairs put a $16 billion Oracle Cerner deployment on ice after an audit found that its failures had caused multiple events of patient harm. Bluntly, you can't use open-source software for financial and medical systems because it simply isn't secure. We assume that Oracle's rewrite is going to be done in Java since Oracle owns Java, but this is still an open-source solution with all the problems that open source has. When something breaks in your open-source solution, there is no one to call. There is no support line, no email, no way to get in touch with the individual who developed your system and caused your problem. We can't be sure what kind of testing the open source code goes through, but we can state that there are as many different testing methods as there are pieces of software. Most of these small, lean teams can't afford much testing at all. The problem is that open source is community supported and maintained. Anyone can sign up to be a part of the community and check in a backdoor to the code that might be pushed with the next release. This could let a bad actor either push a vulnerability to the code base or pay off a member of the community to do it for them. There aren't many bad actors in the world, but there are lots of actors. There is nothing preventing one of your developers from going rogue or being paid to insert malicious code into the infrastructure, the very programming language of your solution. Your developer can put code in the language itself that breaks the whole thing. If not now, then eventually. This is particularly dangerous because the application code should be reviewed by the team, but nobody usually thinks to look in the language itself. Know the technology you are using. Know it well, intimately even. We use Microsoft for all our development and only use less expensive alternatives for infrastructure things like monitoring and virtualization. Microsoft has a free version of its premier software language, C#, that comes packaged with the free product VS Code or Visual Studio Community Edition. Microsoft's premier DB engine, SQL Server, also has a free tier. Though you are limited to size and number of transactions, it is perfect for development. Finally, We prefer Blazor WebAssembly for our user interface. This allows us to mostly retire the old, outdated scripting language, JavaScript, in lieu of compiled, performant, secure C# in the browser. We explained that, so we can say this. There is no reason to use open source when you can use carefully curated complete solutions that are fast, secure, and free. By the time you need to pay for more robust server software, you will have the clientele and therefore the finances to afford it. Further, you would have had to pay for the open source, less than optimal solution at that point anyway. Business can't be left with the task of writing software. There isn't enough knowledge, generally, about how software works to leave this mission-critical, life-depending kind of thing to the people who don't write code every day. The business people generally don't even know enough to hire someone to do it for them. Doctors certainly know what needs to be done, but the mindset is completely wrong for software development. Doctors see individual patients and solve one problem at a time. Developers should try to solve the general problem and then reuse that solution everywhere for similar problems. If we leave the software design to the business people, they will defer to the doctors. The doctors will state that my specialty is different from anyone else's. The outcome of this thinking is that each specialty gets its own hand-coded solution. There are more than 135 medical specialties. This means that the developers have to write 135 separate applications that all do similar, but not the same things. This leads to the Cerner madness and unsustainability. Big insurance mandates that it only accepts current procedural terminology (CPT) codes for processing and payment. The practice also has to supply the correct diagnosis codes that support the procedure performed, or International Classification of Disease version 10, ICD-10, or they won't get paid. All other code sets are proprietary across currently offered EMRs. That means that Epic can't talk to Cerner, Cerner can't talk to Athena, and so on, because they don't speak the same language. Because the various EMR solutions have disparate proprietary code sets, they can't communicate. There are a couple of ways that are standardized for this communication. Health Level Version 7, or HL7, is a text-based way to communicate various kinds of medical information. HL7 channels detailed demographic, appointment, diagnosis, treatment, and pretty much everything you want to know about a patient encounter. The HL7 messages can come in files or networking packets. The problem is that in an effort to cover every eventuality, the designers made it so complicated that most information is transferred in note sections. That is, you have to still write custom code for a message from every sender. If you've seen one HL7 message, you have seen one HL7 message, and you certainly haven't seen them all. The Fast Healthcare Interoperability Resource, FHIR, is from the same HL7 people, but is an application programming interface, API, meaning that it isn't text-based. The sending machine returns a structured packet of information about a particular patient encounter. The problem with that is that now you have to have a developer write code to connect to the remote machine. Then you have the same morass, detailed above. If you've seen one, you've seen one, and you still have to write code to translate whatever it is that they send you, and you still have no idea where they put the information you need. HL7 and FHIR are more examples of the one patient, one solution thinking. Instead of solving the general problem and using that one solution for every similar challenge, medicine looks at one problem at a time and configures a new solution for each, making the total operation bulky, complicated, and unsustainable. Clearly, we can't depend on business people and doctors to come up with software that is designed and coded in a sustainable, maintainable way and plays well with others. If you are a Ferrari mechanic, you may not know how to work on a Maserati. You are a specialist, nay, an artist at your craft. We are not talking about art, however. We are talking about documentation. If your Ferrari needs a water pump, the service writer at the Ferrari dealership writes, leaks water and overheats. These are symptoms. These symptoms do not appear in ICD-10, by the way. The Ferrari mechanic diagnoses that the car needs a water pump, and then performs the water pump procedure. This procedure is different from the procedure the Maserati artist performs, but the documentation is exactly the same. Substitute your healthcare for that process, and you find amazing similarities, including the fact that you do not need a specialized EMR to document patient care. This also means that we should be able to design and build an EMR that only has one specialty and one code set. That would make this EMR 135 times faster to code, sustainable and maintainable. For example, at the Ferrari dealership, you don't have an engine documentation system and a transmission documentation system and a differential documentation system. So why in the world are medical documentation systems written this way? What we really need to build this universal EMR is a universal code set. That is where the smart people at CAP and NHS come in. They came up with the systematic nomenclature of medical terms and clinical terms, SNOMED-CT, a nomenclature suitable for documenting the entire patient encounter. This nomenclature includes well over 350,000 concepts. Even better, the National Institutes of Health, NIH, combined SNOMED-CT, or X-NORM, the National Drug Database, and the Value Set Authority Center, VSAC, into the Unified Medical Language System, UMLS, that not only combines these three, but translates them into a self-referencing and self-documenting schema where the same programmatic techniques can access any of a large number of medical nomenclatures. The UMLS has over 14 million concepts. That means we can translate back and forth from UMLS to legacy ICD and CPT codes, along with the major EMR vendors' proprietary code sets. Since we now have a universal set of codes suitable for doing the job we have to do, we can exchange these codes for all our interoperability needs. Gone will be the days of custom programming code to translate messages from each sender and maintaining all that overhead, custom-coded solutions and infrastructure. Everything just works together seamlessly. In this video, we have shown what the old legacy medical software vendors are doing wrong and how to do it right. We showed how to handle the technology, that there are no specialties, that UMLS should replace the ICD and CPT codes, and therefore how to achieve true interoperability. We have achieved most of this already and are working diligently to complete the balance. Further, we are so convinced that the old legacy vendors can't do this, that we are detailing for the world how and what to do. On a personal note, we had to deal with Epic recently. While HL7 and FHIR are both train wrecks, they work. We asked them for HL7. Epic refused to send data in the standard format. Refusing to send data in the standard format is against the law. Instead, they required us to set up a legacy SFTP server to transfer comma-separated value files. This hasn't been the standard for 30 years since the 90s, and is so far out of date, the Microsoft doesn't support it by default and hasn't for decades. Additionally, every so often they send a file that does not follow the naming convention we agreed on. This morning was one of those times. Our system is fault-tolerant, so processing continued, but our monitoring solution alerted us to the fact that some files didn't process. This all indicates that Epic is using manual processes with zero quality control and consequently causing downstream chaos. These rocket surgeons must be stopped. This is the entire problem with healthcare. The powers that be get something that kind of works, and they cling desperately to it, instead of hiring some real experts to fix the whole overly complicated, fragile system. We here at Century going to fix it, and the solution is to put these legacy vendors and the dumb insurance companies out of business. There is no other way. We are coming for you. Read the text version of this video on our newsletter site, sentia-health.substack.com, or click the link to it in the pinned comment. All of the reference material will also be linked in the pinned comment. We appreciate your attention and help with promotion, and invite you to tell us your thoughts in the comments. We will make every effort to read and answer every comment. Part of the reason we do this is to educate you and help you to educate others. Help us help you and every insured person in the world by clicking like and subscribe, telling the algorithm to show this to more people. Until next time.